Okay, this is 10J. Number 1, find the second derivative for the following functions. Y equals x sine x. The first derivative is x times the derivative of sine x, which is cosine x, plus sine x times the derivative of x, which is 1. That resolves to x cosine x plus sine x. The second derivative, okay, again, it's x times the derivative of cosine x, which is minus sine x, plus, we're still over here, cosine x times the derivative of x, which is 1, plus cosine x. Resolving that, we get minus x sine x plus 2 cosine x. Let's look at b, this function here. We're going to rewrite it. Remember, there's no x term on the top, so we'll just rewrite it like this and to make it a bit easier. We don't need the quotient rule. The derivative of this function here is 2 times, bring the minus 2 down and change it to minus 3, and the derivative of what's inside is 1. So that's minus 4 on x minus 3 cubed, which we can rewrite again, because remember there's no x term on the top. We don't need the quotient rule. So we're going to rewrite it like that, do the second derivative, it's minus 4, bring down the minus 3, change the minus 3, drop it by 1 to minus 4. And then we rewrite that as 12 over x minus 3 to the 4th. Let's look at number 3. We've got s equals 2t times log t. The first derivative is 2t times the derivative of log t, which is 1 on t, plus log of t times the derivative of 2t, which is 2. We rewrite that as 2 plus 2 log t. The second derivative is the derivative of a constant is 0. So this one over here is 2 log of t is 1 on t, so the answer is 2 on t. Question 2, that's the function there. Find the local maximum or minimum points on the curve. So we're going to find the derivative. That'll tell us that. And then justify whether they are maxima or minima. Okay, the first step is to find the maximum and minimums. So we equate the first derivative to 0. We solve for x using the null factor law. For this to equal 0, x must equal 0. And also this part here must equal 0. So x cubed equals 6 on 5. Which is x is a cube root of 6 on 5. Once we know those 2 points, we have to put them into the second derivative to find out whether they're maximum or minima. So we do the second derivative of this function, that's 20x cubed minus 6. We put in the first one, which was 0. And you can see that's going to be a negative number. When the derivative is negative, it's concave down and it's a maximum. So that's concave down. That indicates it's a maximum at x equals 0. And the other one, which is the cube root of 6 on 5, we put that into the second derivative and we find out whether it's plus or minus. Okay, so we go through the process. Okay, and we find out the answer is 18. It'll come up to 18. Now that's positive. So when it's positive, it's going to be concave up, which indicates a minimum. Okay, one other thing we need to do here is it asks for the points. So we've got the x values, but we need to find the equivalent y values. So when x equals 0, we put it back into the original expression. So at x equals 0, y equals 5. And for the other one, is this. We put that back in the original expression and find the y value. And so at x equals 6 on 5, the cube root of that, we find that y equals 2.97 to 3 significant figures. Okay, and B, find a point of inflection on the curve. Point of inflection is where the second derivative equals 0. Second derivative is up here. We equate that to 0. We solve for x. X cubed is equal to 6 on 20. And therefore, x is equal to 3 on 10 to the third. Now we need to find the corresponding y value. We put this back in the original. Don't put it back in the second derivative. Put it back in the original expression, and you'll find that's 3.79. That's three significant figures. Now for C, we have to find the range of value of x for which the curve is concave up. Well, we know the minimum where the curve is concave up occurred at this x point here. So it occurred there. And the point of inflection, which we just found happened here. Okay, now you should confirm this with your calculator. Used your GDC on this and you can see what's happening. Well, obviously, for all x values greater than the inflection point, this is concave up because it's a minimum. The minimum occurs after the inflection point, which we learned from whether it was concave up or concave down back here. So then the range of values of x for which the curve is concave up. Now, concave up means it's a minimum. So it must be to the right of the inflection point. So to the right of that point there. So it must be greater than 3 on 10 cube root of that. Okay.